thanks for coming. This is the session on the current dispatcher refactoring. So we're looking at where we are, what still needs to be done, and how much you can actually use and how much you can see and see what's going on. So we'll do some questions at the end. There is an Etherpad linked from Pathable. I've got a lot more support links and information in that, so please do have a look at the pad. There's a lot of help there and a lot of routes into the documentation and examples and jobs and reports and a whole range of things down from there. So what's our current status? Well, we started with a design of 0MQ to control the job submissions and the actual job control, and we are using XML RPC for job submission. We haven't got a web UI front end, so we don't have the ability to do resubmit either at the moment. But that's all pending later on. We've got the scheduler changes in, so we can actually do the important part of the refactoring, validation of your job before it gets scheduled to actually start running. So you have a schematic check at first submission, very quick check on the structure of the YAML to make sure you've got the right details. That schema is still moving forwards, so there are changes going into that. After that is actually into the database, we then do a full validation of the entire pipeline, which means that we go through all of the actions that you've requested via the YAML. We make sure that all of those have the relevant data in the job submission or in the device configuration to make sure that those will actually be able to run. You get an incomplete job if you are missing parameters or missing values, or you specify the values in the wrong way. You also get an incomplete job if any of the URLs you've specified for download or use within the job are invalid. So they need to be valid from the point of view of the master running the pipeline and the dispatcher that's actually doing the work later on. Once it's validated, then it goes into final scheduling to actually start on the dispatcher. So all of the work is done on the server, on the big database front end. You change the way that the dispatcher actually works, and it's now much more, well, it is essentially dumb. It is told what to do, it does exactly what it's told, it doesn't do anything else, doesn't make any clever decisions, it just does what it's told. It gets the configuration for the device it's actually going to use. It doesn't have any configuration actually on the dispatcher for this anymore. It's all moved onto the server. That's all done, that's all implemented, but there are improvements and other steps to make alongside that. So we've got support for basic TFTP, U-boot, and there's multi-node support. Stefan, you've timed out. Along with primary and secondary SSH. Primary SSH is the equivalent of just having a login on the device. Not all devices will support that, obviously, but some will. Secondary SSH is where you have second connections onto the device. So you boot the device with your test image, and then you start up something that provides SSH, and then other jobs can log into that box and read from files, from output, anything you actually want to do, run test shells as well. It's a normal multi-node job, it's just that you've got jobs there without a device. They are just a connection onto what you've deployed onto the device itself. We've got initial query support. Stefan's working hard on the improvements to that. The main difference from the current dispatcher, it's live result handling. You see the results popping up as the job runs. So you don't lose any jobs if the job falls over in a heap, which, bear in mind, these are development boards and you're trying to test them to show where they fail. That will happen. So we've built that in. It's automatic. It is full debug mode. We control, or we will be controlling what you will be seeing on the web front end, but we log everything. The idea of cutting down what you actually generate on the job is history. That's gone. We're not doing that with the pipeline. Everything is effectively in debug log mode, and then you choose what you view but all the data's there. It means that when you actually have a failure you don't understand, people can actually help you because the debug information is there to work out actually what went wrong.
Yeah, we're able to fold the logs now, so somebody could say, I just want to see the test result and nothing else, and go right to it. And
yeah, the live result handling means that the logs are structured the moment they're actually received. So you have a proper structure to the information in the logs, and therefore we can present them in particular different ways according to what we choose and what we actually support. So they are machine-readable logs coming over 0MQ, and then they're presented to you in another way at the web front end. So that's what's currently in. The stuff we're working on now, obviously ongoing for wider device support. We've got permissions and restrictions ideas. A lot of that is currently in review. It affects how the results and the queries are handled, so that's in development at the moment. UEFI support, both menu and shell, in development. Extending the query support, again, alongside the permissions, restrictions, the results, all that's going on. ADB and LXC in ongoing development. That's a really useful way of changing the behavior for devices that need ADB shells and ADB to push files onto the device without necessarily needing a second box or a second job. With LXC, we are looking at doing it transparently without that extra burden. So those are all currently in rapid development. Installer support depends on some of the previous other ones working and is on the list to be done. And then the migration is just an idea at the moment. We are going to look at exactly how we run the migration in collaboration with QA and building baselines and everybody else once we get through some more of these next steps. And what's available? Everything's available. It's all in master. We are running an example instance which has got all the configuration in place. It is a work in progress. It is tracking master. It's sometimes actually tracking code that hasn't got to master yet. It's certainly not ready as an instance for production or migration itself, but it is our playground, our little test box. But it shows other people what you can do. Other people can look around and see what's actually going on. And you can, if you want to, actually run things like this on your own box. But be aware, you will need to track master. You will need to track what the team are actually doing. It's actually quite a bit of work to keep up with that. And there will be changes to the submission formats and how the jobs work that might not necessarily be announced. So tell us, if you're going to run a pipeline instance for whatever reason, locally, just for your own usage, let us know, and we can give you a heads up when we're about to merge something that changes the way that your current install works. To simplify just the actual production, so this is validation.linaro.org itself, we don't show the results app at the moment, which is a separate utility which is just for pipeline results. But that's visible by default when you actually install yourself, if you're doing master. Sorry, the slide is slightly larger than it meant to be. There we go. What have we got support for? There's a slight change in how you deal with QEMU support. If you're used to the current dispatcher, you're used to the rather false separation of KVM being for AMD64 and QEMU being for particular architectures. That's gone away. It's all just QEMU. So you have to specify that you want the x86-64 QEMU to run what is essentially a KVM job similar to what you're doing already. We are extending QEMU support as well, so that We are able to support multiple images, so you effectively tell QEMU, right, load this, that, and that, and that. And you tell us where that overlay is actually going to go, so that you actually got the test definition in one of them, or we are probably going to move to making the overlay itself another argument passed to QEMU, so that your image isn't modified apart from being decompressed. All these things are in progress. We obviously have RAM disk support for a lot of the ARM devices, and we have NFS. Persistent NFS is in development. Secondary media. This comes down to how we reimagine our devices. The dispatcher tries to protect only the essential components of the device. Essential being, what must we have, absolutely must have, to be able to get that device in a suitable state to run the next job, no matter what your job does to it. So there will be bits of the device that you don't have access to in the refactoring. And that will include, for devices like the Big One Black, it'll probably include the SD card. So that limits some of the things you can do with the Big One Black, but for things like the QB truck, which have got attached SATA, or the Mustang has got SATA, and other devices are quickly coming on with more and more this kind of support, it means that you deploy something useful, something sane, something that gets you a usable set of tools, and then you go, right, I want that media over there, and I'm going to deploy my stuff onto that media and then boot that media. And then at the end, someone else comes along and wipes your stuff away and puts their stuff on it. But you've got the chance now to do proper setups of the full media, and then just tell the bootloader, instead of loading from over there, load that one over there. We haven't got support for changing the bootloader at this point. That needs the fabled SD Mux hardware. Been tried many times. We need a production, scalable, reliable implementation, and we are lacking that, definitely lacking it. Can you use the mic?
You said that the Beagle One Black will have the SD card locked. Is this like all SD card locked? So how can I run anything if the SD card is locked?
Put it on an AMD flash.
Yeah, you've got the eMMC. Yeah. So yeah, there will be options.
The problems with the approach is like Esla approached me yesterday and he said, okay, how do we test LTP DDT, which examines drivers? So we're not able then to examine the AMC driver, right?
You can access the driver, you just can't.
Yeah, but then in order to do it, test what the tests do, they need the partition there. And if it's locked and inaccessible, then sorry, we can't test.
Obviously, this is Beagle One Black. Yeah. It's not going to be like this for all, but we can talk about that use case.
Yeah, we can talk about, but it's, yeah, we're talking at the design level. This is what we're trying to achieve. Individual devices, we might have to work with certain constraints, but equally, it's imperative that we are able to get that board back into a state that is ready for the next job. And without SD Mux, that is difficult. It's a hardware limitation, and it's a constraint on certain devices. But these are the goals we're striving for, and we'll see what particular devices actually need to do at the end. Secondary connections is what I hinted at with the SSH, where you actually have the ability to deploy something to the board, spin up something that acts as an SSH server, and those secondary connections come in and allow you to monitor what's happening on the board. This is really useful for devices that might have multiple serial ports, could use the same mechanism. Devices where you just need to run something, set a breakpoint, see what's happening on that log file over there, whilst having this log file actually viewed on that job and still have control on another job. So the virtualization team have this particular requirement to be able to have all these different outputs.
So something to mention with secondary connections, when you're writing Lava test shell definitions, sometimes you need to spawn a process and put it in the background. and then spawn another process for your tests. So this is where I see this being very useful, because each one of those processes with the secondary connection is monitored in a different console window. So it's easy to separate it. So if you need to monitor multiple processes that you're running a test with, this allows you to do that. Whereas before, we just had to background them and hope they were running okay.
You had to background them and send their output to dev null.
Yeah.
Because otherwise that would confuse the test shell you're currently trying to use. So yes, you get the output of stuff you're actually running. Development stuff, yay. We're putting in the support for job visibility. This is going to be, at the moment, everything in the pipeline is effectively public. So before we can move on to some of the other levels, we have to have support for devices which are restricted in some way or other, and allow public devices to be restricted by the test writer. So that's in progress, that's currently in review. The ADB protocol I've already mentioned, using LXC, but that will also allow you to have an ADB shell. You won't have to think, right, I've got to get an image that has BusyBox. You'll be able to have tests that run directly through ADB. The results and reports, a lot of development going on there. The job overrides. This is the big area, because it's how you tell the dispatcher that you want to do something slightly different. You want to use slightly different boot commands, you want to use slightly different this or that, the other. There's a lot of scope here. We need people to start talking to us over the next few months about how they want to use those kinds of things. Do we make sure we expose the right things and not more than we need to? So there's discussion to go on about how we actually use the override. Persistent NFS is in review. The way that's going to work is similar to how people are actually just hacking it together in the current dispatcher. The persistence is your problem. The security of that persistent NFS is your problem. Whatever's left behind by the test shell, yeah, that's your problem as well. So it'll be easy to identify where Lava has put stuff to support your tests, but we don't go behind the back and try and remount the NFS at the end of the job and do funny things to it. No, it's not an easy way to actually reliably work out what you want done there. So if you can do that yourself, if you want to, the results are logged live. There's no need to have the stuff physically on the media at the end of the job anymore. You don't have any bundle aggregation or processing going on at the end.
Is that for like development use cases like hacking sessions mainly, or I don't see this being useful for any sort of validation, do you?
Yes, the virtualization team have explicit need for a persistent NFS, because they have complex development setups where they've actually got a half-built QEMU, where they've got the entire QEMU source code, they've got all the cross-toolchain compilers and stuff.
So they're actually doing interactive development on the board then?
They're doing interactive development, but they could also use secondary connections and actually automate effectively what they're doing. Okay. So that because they're doing proofing of their own changes on a Mustang board using a hacking session in the current dispatcher, whereas actually they could do their own changes, push those changes as a job, get the automation to run the same thing, because they are just sitting there hitting the same scripts and waiting for the same outputs. So Lava can do that. In development as well, fast models, vExpress, UEFI menus is in review. Alternative test methods, this is a big area. It allows us to actually say, well, yeah, Lava test shell definitions, all your YAML, yes, those are compatible, we're keeping those, we might add extensions, but we're keeping all the compatibility at that level. We can add a new way of testing things, a way that doesn't require POSIX at the far end, a way that doesn't require the same kind of shell, a way that actually uses something you use to connect to the board, like ADB shell, like something that interacts directly with a UEFI bootloader. You haven't got a real shell at that point. You've got something that's pretending to be a shell, or pretending it has limited support. So we can design support that actually runs the tests you want in there, get the results out live over ZMQ, and move on. Now, early on in the week, we had a user forum, and We were expecting a quite diverse range of things that people wanted to have out of Lava. Turned out there was one big topic that everybody wanted out of Lava. That was the documentation to be made easier to use. We had a big effort at a previous Connect. We put the entire team on writing documentation. Now we need help, effectively, because documentation written by developers usually isn't that helpful to users. So that's a large area that needs to get done. Structural changes and content changes. Okay. So can you use the pipeline? Yes, you can. There will be changes. Talk to us about how you actually use the job submissions. There's an example Git repository there, refactoring.git. We keep that up to date. We work on keeping it up with master. There'll be a lot of new methods and new support coming through. And the implementation is all done on the Lava server. You can do some testing on the dispatcher, and there are ways of making sure that works nice and easily. But the main thing is that the submission comes through the server. The server does some preparatory work on making up information from the device and from the database, and then say, right, that's a job with its device configuration, sends it over ZMQ, and it starts. The other part of that, obviously, is the results app is in ongoing development. That will change quite a lot. We do have support in that already for exporting to CSV and YAML. There's a lot more data that's actually available for you already. Things like, exactly how long did it take to clone that Git repository for my test shell? Exactly how long did it take to get through that particular action? All of that is automatically logged. How are we going to migrate? This is something we will still need a lot of talking over with lab team, building baselines, QA, the whole of the automation team. But the principle is going to be this way. We're going to add more and more pipeline support for existing devices. That will be supported by functional tests running through staging, as they are currently running through Playground. Development of new test definitions based on use cases to start working with the teams on. And then you get to the point where you've got enough usage of the pipeline on a particular set of, whether it is a particular CI loop or a particular development team or one particular set of users, you get a nice little cohesive set and you migrate them all over. Once you've done enough of those, you get to the point where those devices are no longer running JSON jobs, so you can turn off the JSON support and they only accept pipeline jobs. Once we get to the point where all devices have had their JSON support turned off, then we can actually start removing the old code base entirely. We just drop it, throw it out. Git RM, it's a lovely tool. When? So we're looking to have production using pipeline devices the end of next year. We're looking then to remove the old code base simply because it will be getting in the way substantially by then, by the end of the following year. So this will be fully announced. There'll be lots of talk on the mailing lists and lots of people actually being told what's going on. But the current dispatcher, its days are numbered. And it's the end of 2017 is the expected execution date.
Doomsday.
Doomsday.
How are we going to get the message out to... Sorry. There are other Lava instances in the world than just production, right?
Yeah.
Just the Cambridge lab. There are ones we know about. There are ones that we don't know about. We're going to need to get this message out really effectively to work with those people who are running it, or we're going to have to help.
Yeah.
I mean, Collabora is an example.
Yeah. Yeah. Collabora are already looking forward to using the pipeline. They keep asking me when they can start using it themselves.
Yeah.
They are probably going to be one of the first to actually do the migration. But yes, we keep on finding that people pop up on IRC or pop up on a mailing list and say, I'm using deployment tool. And you go, what?
Yeah.
What? What?
The other issue is, I don't know how many people with installed Lava instances upgrade regularly. So I know ARM does, I know Collabor does, and I know we do. But I'm not aware of anybody else tracking the development. And so that's the other issue, is that they might just say, well, we've installed it, it's working, we're never going to touch it again, and never going to upgrade. So
they are effectively running their own fork already. And people who do that know the risks that if they're running a fork, then they know.
You might hope they know the risks.
Do we currently encourage people?
Do we currently encourage people to get in touch when they install at all? Do we have a users mailing list?
That's a good idea. A users mailing list would be a good idea.
I think that's a really good idea.
Do we have an announcement mailing list so that people can at least track that and get updates on changes and releases and things?
We have Linaro validation. We might actually have a full announcement list.
Yeah, that's probably a good plan.
Yeah.
Can we do something with the Debian packaging? So when we do delete it, like there's some sort of message, it's like, hey, this is about to change how your installed system is going to work. Do you want to do this or not? And then if you're in doubt, like, send us an email to this mailing list or come look at this website for more information.
Yeah. So that's something we would put in during the lifetime of after we've done our migration and we start to think about actually putting those changes in. Well, the package installation setup will change. All the current questions for the remote workers and the other stuff that is based on the current dispatcher, that will need to be dropped, but it'll only be dropped after we've done the migration at some point before we start removing the code. So there'll need to be other ways of making that clear. But yes, my particular issue, I suppose, is people who just install Lava from Jesse. They are effectively, they won't have a way of being told about these upcoming changes. But stretch will be when, do you think, Steve?
Well, it's probably going to be something like April 2017.
Yeah. So that's okay. So we will certainly build into, when we start seriously putting effort into Lava Server being in stretch as a stable release, there'll need to be effort in there to make sure that there's information for people installing and information about all the rest of it. And but there are ways of doing that inside Debian.
What about a new, yelling loud enough, I think I picked up here. What about if we actually, version it? Like, so when we get to that point and we're going to delete the dispatcher stuff, we actually say this is Lava, V2 2.0 or something like that, and we create new packages at that point that reflect that. That way, people aren't going to just automatically upgrade, and then it's like, oh my goodness, I don't have a workable system anymore, and I didn't understand.
There are also standard ways in the packaging to actually prompt the user to say, you seem to have a database from the old system. If you just upgrade this, it's all going to go to shit. You need to know about this. Yeah, and give people the chance to abort the upgrade.
We could probably be a little more polite, but...
Well, yes, quite. You know what I mean?
Yeah. Yeah, it would use the same principles as we're already using for the remote worker stuff. The complication with that is that because of the problems with the remote worker and the SSHFS and all the other complexities of that, when you're installing Lava even now, you do have a bit of a wall of text, and the temptation is just to
so I like the idea of having Lava V2 as a completely separate package, and if somebody is installing the old one, they get a warning that this is no longer supported, it's deprecated, it's no longer supported. You should be looking at Lava V2 or whatever.
There's already a meta package, which was, yeah. 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 If someone can add that to the Etherpad, it'd be very handy.
So the current refactoring repo seems to have the devices and device types as well. Will the developers be able to, like the test definition developers, able to change those at will, or will they eventually be separated to a different repository?
The device types and devices in the Lava Dispatcher code base are solely there for the support of the unit tests inside Lava Dispatcher. They are generated files that well, they are copies of files that will be generated by Lava Server, but they are stored in the dispatcher to support the unit tests. What will happen on the Lava Server is that the device type will be a database entry. It'll have a lot of extra information put into it. Underpinning that is a Jinja2 template, which supports all of the different methods and the representation of that from there. Test writers will have ways of using the job overrides to specify different commands for the device. But that need to be supported via the template in the Lava Server. So we will go through exactly what use cases, and we'll make sure we have as much control for the test writer as possible. If I just...
I think we want to expose as much to the test writer as possible, but I think there's going to be some sort of decision that needs to be made on what variables they can modify and what they can't, and we haven't really got there yet.
So when I looked at the Git repository that was pointed in the Etherpad, there's a device type definition for QEMU, which has some command line options and others depending on architecture and so on. I guess the if and else stuff there is the Jinja2 template you mentioned.
Yeah, so the QEMU device type in particular was one of the very first ones to go in. It has already needed updates for support that's coming through with the multiple image deployment. There will continue to be upgrades on that. I'm aware of the kinds of things you need to do, and the change that's just gone in this week that Tyler worked on originally at the sprint and Dean finished off during this Connect, that explicitly allows for a range of arguments to be specified directly to QEMU. That can also be extended to have full control over everything except the QEMU binary itself. So we'll control that you actually launch a particular binary that's pre-installed on the system. If you want to run QEMU from a local build or your test build or some other experimental version, then you use something like the secondary media, or you use a test that actually puts that onto a system and you run it from there. And then you have the secondary connections as well to be able to monitor what your different consoles are actually doing. So yes, there's still a lot of work to do on there to actually identify how you get into different stages, particularly with things like Zen. So we'll be talking to you during these ongoing stages about exactly what you need and how to do it. But it'll need the support that we're doing already for the different types of test, because at that point you haven't got a POSIX shell, you're just dealing with Zen support. So that becomes a protocol of its own, and we need to work through how to do that, and then we can talk to systems like that at stages before they actually get to a boot prompt.
So the work I've done on multiple image reports, and Dean's been kind of helping to close that loop. The use case was I wanted to boot Android with QEMU, and it requires different partitions, so it's different QEMU images. And so when I was looking at how to do this support, I realized that our device configuration wasn't providing the right QEMU options. And so we built in this way so you can name an image, It's arbitrary. The job writer says this is a rootfs image, and then you can specify the image argument command, which will be passed to QEMU as the command is built up, and allows you to use a variable replacement. So you can say, this is the name of the image. Lava is going to replace it for you, but you put it anywhere in the string where you need it, so that the QEMU command line is exactly what you want it to be. So we've got that, but I think what Neil was alluding to is that we still need to provide ways of also adding additional options that you can configure arbitrarily, and potentially even which QEMU binary we're going to use, because it would be nice to just dynamically say, I want to use QEMU AR64, and then I want to use
that's
something
already
completely-
in. So which of the pre-installed QEMU binaries you can use, yes, the support's already there. It's just that we are trying to protect the dispatcher and let the lab determine which version of QEMU is actually hardwired onto the dispatcher for other people to use for their tests.
I'm not really interested in running the QEMU on the dispatcher. I'm interested of the use case where I run QEMU on the Mustang. So I
Yes,
guess
exactly.
in that case, the pre-installed QEMU is irrelevant.
Yes. Right. Yeah. When you've got a deployment onto a device, that's entirely your own little world there now. You just need to make sure that the bits that we need to protect are protected. So in the case of the UEFI, of Mustang, that's going to be either UEFI or U-boot. The rest of it, it's entirely up to you. You can do whatever you need to do on that, and we'll strive to give you enough support to make sure you've got all the tools you need to actually put that into place.
So if I run QEMU on Mustang, would I use the QEMU device type still, or?
No.
Okay. Now it makes it more clear.
Yeah. You can use it. You can just run it as a
secondary
command.
connection, right? So
Yeah.
you would basically get n number of lava shells into the Mustang, whether that's over SSH, and you guys could then just say, here's the QEMU command to run, and then execute your test inside of that. Is that more flexible for what you guys
Yeah.
Okay.
Yeah.
So do we have an example of a situation like this yet in there?
You've got a BeagleBone Black that has multiple
Yeah.
connections, so that you could do that, but just take it and move it to Mustang. Right?
Yeah. Yeah.
Mustang support gets there. Actually, we have Mustang support already, right?
We do have Mustang U-boot support. I'm working on the Mustang UEFI menu support. So this is the guidance we are putting up for ourselves as developers and for everybody else in the documentation. This is the particular section on that. Give the test writer enough rope. If they hang themselves, that's their problem. All we need is the ability to reset the board and let the next test writer's job work cleanly. But we are working to give you as much room as you need, as we can give you, as much room as possible. Some of the other guiding principles I've hinted at already: only protect the essential components. Try and treat the deployment as a black box. So once we've booted that thing for you and you're in whatever test environment you've actually specified, it's hands off. It's a case of it's your test. You do what you like from there on. And let the test fail and diagnose later. So we're trying to add support where we know that there are particular issues. We don't run the diagnostics every single time, which seems to cause issues with the current dispatcher because it has assumptions about whether the network comes up automatically. So no, it's a case of if the particular pipeline needs network, it'll try it and then diagnose afterwards the network wasn't up. The big problem with the current dispatcher is defaults and assumptions. Those are going away, and that's deliberate. We're making sure those are out. Yeah.
Can you elaborate on let the test fail and diagnose later? So, for example, would there be support for something like a interactive hacking session on fail? So, like, is that what you're talking about?
There is a clear use case for that, and that is something we are already thinking about, how to actually do that. In many cases, it's going to depend on exactly what kind of test it is, whether you've can actually get an open SSH or a connection onto that board in the first place. Because obviously, certain tests, you might have actually ended up with a failure at a point where the network's down, the package isn't installed. Oh, hang on, that's not going to work. But where there is support for doing that, and again, if you get into that situation and you've set up the test to try and spawn a hacking session on failure, and you get to a point where the hacking session is triggered but can't run, you'll get a test error. And that's your problem. But yes, those are kinds of things that we can actually put in. The other part is that there are ways of specifying on failure, retry this action. So we'll go right the way back to the top of the action and retry it again. So those kinds of things are built in.
Thanks.
First of all, I'd like to apologise. You can work out what for later. I missed the beginning of the session, unfortunately. You were talking about refactoring, dispatcher and things like that. Now, something I'm interested in is trying to help you guys clean up the mess I created with Juno and Versatile Express. And did you cover that earlier? Or
No. So VExpress and Juno, so we need to get things like the job visibility stuff finalized and in master before we can really start working on that, because a lot of Juno stuff still needs some level of privacy and restrictions and that sort of thing. So that is one of the things that's coming up next, and we are going to be needing help from Dave and yourself and other people to actually work this out.
Dean's planning to be working on that, so
Yeah.
you guys keep in touch about as that integration's going.
But, I mean, Neil and I have regular conversations about Junos and Versatile Express and the whole menu system and the oddities. And
so that's the whole big thing. It's not just it's not just a case for me of refactoring the way your code works or something like that. For me, it's actually, I think the way that we actually boot the boards and the way we put the software on and things like that, that's all been directed by me to you, right? And maybe that, if you think that's, you can see why I'm apologising. But I think there's lots of ways we can do that better. And Dean and I had a meeting about a week ago, and we talked about some of these things. But I think it's not. The details obviously aren't for here. But I think at some point perhaps we need to sit down in Cambridge, and I can show you some of the things on the Juno board that actually make it a lot more usable than the way we use it today. For example, we can try and work something out.
The current Juno support is constrained by the current dispatcher ideas as well in many areas. And this whole thing just opens it out so much more. The possibilities become much wider, and we can implement it to have a very wide range of options. Because that's the main thing with the dispatcher, is the refactoring, is to give the test writers more and more rope by giving them all the different methods, and they can just choose between the different ones. Well, rather than asserting we do this and we do that, and we must do this every time. As long as we can get to a point where the different methods allow us to get back and reset the board into a known state, that's the primary criteria. Everything else is open.
So let's talk about UEFI real quick, because it's been obviously a little bit of a pain to work with in the past. So what I'm thinking is, do we want to treat it like a first stage bootloader and just say, we support UEFI platforms, we go right to Grub, and we interact with Grub directly because we have more control. Like, we don't control load addresses in UEFI. That's right. And so it doesn't even make sense to be mucking around in UEFI.
I think this is part of the things. This details. Yeah, you're right. I think if you talk to Leif, and he will tell you we're doing exactly the wrong thing on these boards. Right. The fact that we're messing with this UEFI menu, we shouldn't be. We should be loading into Grub, or we should be at the moment we're using UEFI as a bootloader, right? And that's our fault, not your fault, sort of idea. You know, that's the way I told Dave it worked, if you know what I mean, things like that. That's all fine, but we can change that. And we shouldn't be using UEFI as a bootloader. We should be loading a bootloader and then taking it as that chain. And they're the types of things I want to change, really. And so then you're not having to parse the menu system or crazy things like that.
We use it as a method to
we can support doing the menu stuff anyway for those people who want to test that.
Sure. Well, of course, there's the two cases where you're testing an image and you don't care about UEFI, and there's also the cases where you're testing UEFI. And at that point, you do need to interact with it, but that's an entirely different test class, of course.
And what's happened at the moment is those two use cases have been merged into one implementation.
Absolutely.
And that was wrong.
Some separation there.
And the refactoring will make that separation easy. You'll have a clear set of, well, this pipeline is just going to use Grub, that pipeline over there, you specified, I want to test UEFI, that's what you get.
Potentially another pipeline to use U-boot.
You won't necessarily even need to go from UEFI into an image. You might be able to, I'm hoping that we can get this protocol support in right, so
Yeah.
that you can just interact with UEFI, test everything about it, and try its failure modes, and then just turn the device off.
Yeah.
You can boot an image if that's part of the test you need to do, but just interacting with and that does require that people who are actually developing UEFI have a chance of testing the menus, because that is an area that needs support and needs validation.
Yeah. Cool.
I guess I just wanted to comment about that. So with Leg, I guess with Leg, we kind of want to use UEFI to boot, ACPI and all that stuff. But yeah, we're kind of falling for the big data and the software-defined stuff. We kind of fall in that first case where we don't want to touch UEFI. We're not testing UEFI.
Yeah.
We just want to get through it.
Yeah.
So now a question. Since if we wanted to deploy a new deployment, a new instance, do you suggest that we just jump right into this V2, and then that way we don't have to mess with hacking the old?
Not quite yet. This is
Okay.
this is the dilemma. We need a lot of the current development in place. Now, if we go back to this, if this support is all you actually need, then yes, you can go ahead and deploy a pipeline instance. But as I said earlier, do let us know, because even bits of this might actually change, particularly the submission formats. The visualization is in development. So you're going to need to track with us if you're going to install a pipeline and expect to get production type results out of it. If you want to install the pipeline and just play with it, go ahead. But if you're trying to use it for real engineers and real CI work, then you're going to have to dedicate someone to work with the team here and track what we're doing and talk to us.
Right. So I'm thinking. I mean, my thinking is, I wonder if it would be easier to have somebody track with you on this for our use cases than try to stick with the current version and try to make that fit something it wasn't made
What
to
I'd
fit.
suggest there is talk to probably people like the lab team, like Dave, about what your use cases are, and Tyler, about what your use cases are for the current dispatcher and how much modification you might need, as opposed to what you think you might need now. But talk to the people about what the options are, how big is the delta you need from what we've got in the current dispatcher to what you actually need. That would be a big factor in whether you actually move to the pipeline now or carry on with the current dispatcher and effectively have a local small fork. Because the big thing with the dispatcher as it is now is the changes like the ones you're thinking of are too intrusive and too dangerous to put into the master branch and into production, because they'll break other devices because of the way that the current dispatcher is a bit of a spaghetti code problem. You won't have that issue because you'll be running a local fork instance and you can ignore all the other devices, you haven't got them connected. That would, it becomes a much bigger problem for Dave and the lab team and production when we actually put in one of your changes and it breaks some other random device.
I think it also comes down to your timeline, right? If you need it,
Yeah, timeline is
if you need to have this CI loop up and running in 3 months, it's not feasible to use this. But if you just want to track it, try to make sure your use cases are eventually supported, then I think it's the right thing to do is to track it closely and watch it. It's just, we get people coming to us and say, well, I've got to deliver something by January. Which one should I use? And the clear answer is use what we currently have that works. So does that help?
What's the timeline for this being ready to use? Not fully deployed, but ready to use?
You want to go back to your slide that had that?
There you go.
We're a minute
Oops.
over. There you go. So, yeah, end of 2016, having some pipeline devices mixed in with the regular devices in the validation lab, and then full switch over, hopefully end of 2017, exclusively using the new dispatcher.
So by the end of 2016, we hope that the majority of devices in production will be exclusive to the pipeline.
But that's different than when is it ready to use? Yeah. So when's it ready to use?
When it's ready to use depends on which methods you need to use, because the new dispatcher is method-based. If the method exists, then applying that to a new device or a new instance is trivial. So if, that's why I went back to this one. If this kind of support applied to a different device possibly is what you can actually use, then you start with that. As new support comes in, if that method is something you can use in your situation, you can adopt it and use it. You don't have to worry about, oh, I need to do a full-scale migration. We are keeping the two in parallel at least until the end of 2016 to make sure that we've got the production support in place before we can turn it off. So you've got that time frame where you can use a mix of JSON jobs and refactoring jobs. They'll carry on being supported, and it'll depend on how you need to handle the methods that you've got. The limitation with that is, of course, we are fundamentally changing the way that the results are handled. So if you've got a CI loop that has some JSON jobs and some pipeline jobs, that's going to be complex. There's nothing we can do about that. We are not supporting migrating bundle data into refactoring or vice versa. We haven't got the team support to do that. So these are things to think about, how you actually manage the eventual data. But then, you know, Lava and its visualization is a general case, the common baseline. A lot of teams actually require to pull the data out of Lava, stick it in their own front end, make it relevant to their own developers, and then if you're doing that, the API is the same. You're just getting more data out of the refactoring.
I think we're over time, so we have to.
Yeah, I think we're done. Thank you, everyone.